So I have a question for Beth Lomax. Two quick questions. First, when you did your sintering, was it on a loose powder or did you do compressed pellets before? And the second question would be, are you planning to see how its mechanical behavior or compressive strength or something like that?
No, we didn't compress it at all. As I've mentioned, for molten salt electrolysis, we want to have the highest porosity possible. So inside the crucible, we just very gently flattened the surface off to try and make it a flat pellet surface, but there was no pressure involved at all. And similarly, we don't plan on doing any kind of mechanical testing because it's inherently destructive and we need the pellets for the main experimental goals. So we need them to be completely intact. And we know that it's not going to have wonderful mechanical properties because it wasn't, we weren't aiming for that, or aiming for high porosity.
Next question, please.
Again, also for the FCC molten salt processing, based on the two samples already tested and kind of the expectations maybe for the future ones, is there any expected preference for one of the samples, whether like either the region or the maturity that's thought to be better for the purpose of the molten salt processing, or is it that's all kind of the same?
So haven't done any molten salt processing with these pellets yet. Just done the first sintering set, and I'm aiming to complete the sintering and do all the analysis necessary before the molten salt part of the project starts, because it's quite destructive, so I can't get the pellets back. My expectation would be that the form of the pellets will have a much larger impact on the process efficiency than the composition. Of course, there's variation with the composition. Typically, things like iron oxide that are more prevalent in the Mare region material, they reduce more readily. But the thing with the FFC process is that we can reduce all of the oxides present. So I think actually the very small closed pore structure of the mature material that had the much finer particle size average is going to have a larger impact to kind of hinder the salt access to the internal pellet.
Okay, thank you very much.
Next question, please.
Can I have then one question to Francesca? You said now it's actually inherent from the prosper drilling. So the size-wise is going to from 1 meter to 10 meter depth, right? So is there any technical challenge when you dig into 10 meters?
So the question is about the challenge to reach a deeper depth deeper than 1 meter. Yes, the idea in this concept is indeed for the drill to identify the critical part, focus on that. We know that it is challenging, and that's why we want to investigate these challenges. So all the critical parts for the extension road, it's very complex because we have to think to longer roads. We know that for reach this depth is not very easy and feasible. That's why we are investigating new concept. Thank you. I hope I have.
Yeah, sure.
There's a question for Victoria. Would the mass spec require any like in situ calibration, and could that be contained within the 1U area?
That's a really good question. I guess yes is the answer to that, probably. Based on the fact that if we're deploying it anywhere on the lunar surface, we're going to have different conditions, different amounts of water, different potential volatiles that we'll find. Could it be contained within the 1U? That is something, probably not 1U, but within the CubeSat form factor, yeah. This kind of tool is designed that you could kind of add lots of different kind of modules onto it. So that could be something maybe that could be part of another solution kind of to use in situ.
Okay, thank you. Is there any more questions? Okay, then maybe we can move on to next stage.